Hi, my name is Ryan Shukla. Today I'm going to talk about how Mitchell, Adam, and I designed a simple neural network from scratch using MATLAB. We'll also demo how our network can be used to predict stock prices. So first of all, what is a neural network? Well, neural networks are inspired by the way that actual neurons in the brain connect together in complex ways in order to make complex decisions. This is a diagram of an artificial neural network. As you can see, it looks a bit like a simplified diagram of a brain. Each of these circles is an artificial neuron, or a node. You can think of these nodes just like real neurons, except instead of firing electrical signals, these nodes simply pass numbers to each other. These numbers are known as activations. What makes neural networks useful is the fact that, like real brains, they can 1. Be trained, and 2. Solve difficult problems which are hard to program an algorithm for. Some applications of neural networks include the self-driving car industry, as well as market trading and finance. How does a neural network learn? Well, as these nodes pass numbers to each other, these numbers are assigned weights. If we get the values of these weights just right, then the neural network will give the output we desire. The process of finding these weights is known as gradient descent. In gradient descent, we make many small adjustments to the weights, allowing the network to slowly get better and better until it can give us good predictions. To run the code, type in run_network. We're going to train using the default network. An instance of the network class will be initialized and trained using the default parameters. When training is finished, a plot of cost will pop up. This shows the error in the network after each successive run of the gradient descent algorithm. As you can see here, the cost approaches 0 and stays around 0 after each successive run of gradient descent. This is a good sign. This means that gradient descent has probably worked. Sometimes you may find that cost does not approach 0. This means that gradient descent may have failed, and this happens sometimes due to the fact that we randomly initialize weights and biases. If that happens, simply run the code again. In this case, the cost looks good, so I'm going to test. We're going to not train again, and we're going to test using the default data. Here, we have a plot of the predicted stock price versus the actual stock price. Each point on the red curve is plotted by the neural network based on the previous 4 days of data from the green curve. Once you're done testing the network, the code will output a network object. This network object can be saved for later use, and its weights and biases can be examined to see the results of gradient descent. Now let's talk about our development process. Our first steps were doing research. We needed to learn about gradient descent as well as the equations for backpropagation. We also had to plan how we were going to write the code. We decided to go with an object-oriented approach. We also planned out how we were going to modularize our code. Because of the way neural networks are structured, we needed to create one function before moving on to the next. For example, in order to backpropagate, we first need to feed forward. So as you can see in our commit history here, in February, we set up our Git repository and also started collecting data. We collected stock data from Apple, Google, Tesla, and Microsoft. Once we had the data, we began creating functions one by one. The final step in the development process was to fix any last-minute bugs that occurred when putting functions together. We also created the user interface. This was, in a sense, our only working version of the project, since intermediate versions of the code were not fully functional, since every function needed to be working before the network could be trained. The hardest function we found to write was the backpropagation function, because we needed to figure out how to get these calculus-based equations to work in MATLAB code. We also had to do a lot of trial and error to find the best parameters for the network. We were initially using a learning rate that was way too large, and our numbers were all going to infinity. We also found that too many nodes created a noisy graph. A final challenge we had was learning how to use Git and GitLab for version control, as this was both of our first times using Git. Here are some of our best results trained using stock data from Apple in 2016 and tested using 2017 data.